Hello everyone, welcome back to our IGCSE Math 0580 Extended Revision session. Today we'll be doing Unit 9 Statistics. So in order to do statistics, you first need to know how to interpret the data. For example, we have data of number of apples owned, and we have like 2, 3, 7, 8, 9, 1, 0, 10, 12, for example. And then first, what is the average or the mean? We have this sample and the size is 1, 2, 3, 4, 5, 6, 7, 8, 9. Size is 9. So in order to find the average, we add them together. 2 plus 3 plus 7 plus 8 plus 9 plus 1 plus 0 plus 10 plus 12 and divides by the sample size, 9. So the average for this would be 52 over 9, which is 5.78. And since apples can't be in decimals, we'll round it up to 6. Now, then, what is the median? So for example, to find the median, we first have to order it by size. So we'll have 0, 1, 2, 3, 7, 8, 9, 10, 12. The median is the middle number. We have odd number of samples, so it will be the fifth, which is 7. If we have even, for example, we have another 1, then it would be 3 plus 7 divides by 2. This will give us 5. And now the mode. Using this sample, mode is the value that has the most appearance, which here is 1, so mode equals 1. And you can compare datas using these identities. For example, if this is like city A, its average mean is 2 apples, and city B, its mean is, let's say, 5 apples. You can say that on average, city B has more apple ownership than city A. Now, how can we do this by graph? For example, we have a box whisker graph, and this would be something like this with a number line on the bottom, like 1, 2, 3, 4, 5, 6, 7, 8. And this will be the minimum value. Here's the maximum value. This is Q3, this is Q1, this is the average. Now Q3 is the upper third quartile and first quartile, which is the 75th and the 25th. So like if we have, let's say, like 10 values, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then the average for the second quartile would be 5.5, and third quartile would be 8, first quartile would be 3. Also, the interquartile range would be 8 minus 3, which is 5. And going back to comparing graphs, so let's say this is city B, this is city A. So like we can say the average of city A is smaller than city B, and city A has a greater interquartile range because obviously length for here is smaller than here than city A. And if city A looks something like this, instead, we can say that city A is more compressed, or city B is more spread out than city A, because like the range is smaller. Now move on to charts. So first, let's talk about bar charts. Let's use apples still. Like for example, apple yields of cities. We'll have city A, let's say 50K, city B, 30K, city C, 75K. A bar chart looks like this, with its y-axis being, let's say, 50, 100, 75, 25. And the unit here is apple yield units in K. And the x-axis would be cities. City A, city B, and city C. So we should draw a bar aligned with its value. City B is 75, so it's here. And city C is 30, so about here. Bar charts are really good at comparing data, so we can obviously see among these three, city B has the most yield, then city A, and then city C. Now, for pie chart, let me draw a small bar chart here. Now, for pie chart, it could be looking something like this. So, example, like size of apples. We have 100 apples, and 25 of them is small, 70 of them is medium sized, and 5 of them are large. Then for a pie chart, here's a circle, and because we have 100, so we know that 25% is small. So we represent it like this, and we write small, and 70 of them medium. So it would be like this, medium, and here would be large. This is 70%, 25%, 5%. And this is, we can see the ratio very easy. See the composition of the size of apples using a bar chart. Now, tally chart. Tally chart is usually used when we're gathering data. It could be something like this. Here's a chart, and axis, or like this. So when we're doing, for example, a survey of fruits bought, and for example, we have a chart here, and we have type, frequency, and we have let's say apple, peach, banana, and let's say melon. So could be like this. For example, 1, 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 1. So we can tell there's 8 apple spot, 2 peach spot, 12 banana spot, and 1 melon spot. And now a two-way table. So for example, we have gender and sport plate. And we have male, female, tennis, badminton, let's say. Badminton, sorry. And let's say 25 may, or we need a total here. Total. And 20 of them play tennis, 30 of them play badminton, and 45 female play badminton. So the total tennis player would be 45, total badminton player would be 75, total male player would be 55, and total female player would be 65. So the total number of sample number be 75 plus 45 or 55 plus 65, which is both 120. A two-way table is mostly used when there's like two variables, for example here gender and sport play. Now pictogram is similar to a tally chart, but instead of x's or like countings, it will be a unit given. For example, unit of, let's say, a star equals 5, and um, for example, rating for coffee shops, and we have like coffee shop 1, coffee shop 2, coffee shop 3, whatever. And instead of numbers, the data will be in the form of the unit given. So we have 1 star, 2 star, and 3/5, 1 star, and only a point, 1 star, 2 star, 3 star, and 4 out of 5. So we can tell that this is 5, 10, 1, 2, 3, 3. So 13, 5, 1, so 6, 5, 10, 15, 1, 2, 3, 4. So 19, because a star is 5. So 1/5 of a star would be 1. So this is a pictogram. This little boy. And stem and leaf. So stem and leaf would be, for example, we have height in company A, employee's height in company A. And we have, let's say, 160, 163, 165, 170, 178, 179, 180, 181, 190, 215. Then in stem and leaf, we'll do something like this with, for example, headings 16, 17, 18, 90, 20 written here, and values here will be ordered from small to large. So 0, 3, 5, 0, 8, 9, 0, 1, 0, nothing. So 21, 5. And the key, we have to do this. Key 16, 0 equals 160 centimeter. So picking a random number, for example, 118 would be 181 meters tall. Just remember when you are finding the value for the stem, usually leaves, value for the leaves will be only 1 digit, so like this, but it could be 2 digits. Now move on to scatter diagram. Scatter diagram would be usually drawn in a 2D coordinate plane, like giving data points like this. So you can just mark it normally with its coordinates. And what you need to do is first the correlation, and second, line best fit. So first, correlation. This graph here will be positive correlation. It's going to the positive direction. And if it's like this, an obvious negative trend, it would be negative correlation. And if it's scattered all over with no trend, it will be no correlation or zero correlation. Now, how to draw line best fit? Line best fit, in this example, we should draw by hand. It will be a straight line, passing through as many points as you can while keeping the number of points on one side equals number of points on the other side. Here's a bad example, but like if my line, because like I don't have a ruler, but like if it passes through these 3 points, then it's a line best fit because we have 1, 2, 3, 4, and 1, 2, 3, 4. And actually here this one will be an anonymous result because it's way apart from the other data points. And now cumulative frequency diagram. So in order to do this, first cumulative means adds on, keep adding, and frequency. So we first need a frequency table. For example, the sample would be time taken for a crossword puzzle. And we have time being, let's say, 10 to 15 minutes, 15 to 20 minutes, 20 to 30 minutes, 30 to 60 minutes, and 60 to 100 minutes. And this is minute, this is frequency. We have 150 people surveyed, sample size, and we have, let's say, 20, 30, and 75, 25. So this will be the frequency. This means there's 20 people took 10 to 15 minutes to finish the crossword puzzle. Now, how do we calculate the average? What do we do is we can only do an estimate average, which we take the middle value of each class width. So here would be 12.5, here will be 17.5, here will be 25, here will be 45, and this will be 80. Then we times the frequency, times frequency, times frequency, times frequency, times frequency, and divides, so add them, divides by sample size. This is how we calculate average. And now how do we draw the cumulative frequency? So it's cumulative, so we know that it adds on, which means instead of say, like we have this frequency table, now we can make a cumulative frequency table. Cumulative frequency table. So instead, we'll only have 10, so like smaller than 15, we'll have 20 people. Smaller than 20, we'll have 50 people because these 20 people have times smaller than 15, but they're also smaller than 50. So the frequency cumulates. Smaller than 30, we'll have instead 125 people. Smaller than 60, adds on 20, 145. Smaller than 100, we'll have 5. So in order to draw this diagram, let's just do it here. because we need a table. We'll have time on the x-axis. So for example, let's say like 15, 20, 25, 30, 35, 40, till like 100. And we have the frequency here. Remember, it should be in scale. So 150, here's 0. Here is like 75, and we mark it. So when it's smaller than 20, it's 50. So I have 20 here, mark it 50. So about here. Smaller than 30 is 125, 30, 125. It'll be here. Smaller than 15 is 20. Don't forget that. Smaller than 60 is 145. Smaller than 100 would be 150. So the graph looks with a curve looks something like like this. And now I don't know what happened here. This is 145. Given the graph, we already have the graph. How can we find quartiles? Q3. We know that it's the 75th. So we 150 times 0.75. We get a number, and we use that number. We find it on the y-axis, mark it, and find the corresponding x value, which is here about, what is this? This is 25, so like let's say 27. And Q1 would be 150 times 0.25, which is about 47.5. So it'll be something like around here. We mark it, find it. So lesser than 20, let's say 18. Then the quartile range would be 27 minus 18, which is 9. Now histogram. So in order to calculate histogram is also called a frequency density graph. So we have, again, let's say time to finish the crossword. What's our values again? 15 to 20, 20, 30, 30, 60, 60, 100. And we have 20, 30, 75, 25. So in order to draw a histogram, we need to calculate the frequency density. Now, since it's density, we know that density is mass over volume. And in this case, what's the volume? The class width is the volume, and the frequency is the mass. So frequency density here is 20 over, what's the class width? 15 minus 10, 5. So 4. 30 over 5, 6. 75 over 10, 7.5. 20 over 30, 2 over 3. 5 over 40, 1 over 8. So when we graph a histogram, it will be similar to a bar chart, but so here would be class width, and here would be frequency density. Just remember it has to be in scale. So if it's something like this, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Then our first part, 10 to 15, with a value. So let's say this is 10, this is 5, this is 0. We have a value of 4, so it will be a bar like this. So here will be 15. Then 6, we'll have a class width of 15 to 20 with a value of 6. It will be here like this. Now 20 to 30, we'll have 7.5, be like around here. And we have 30 to 60 with around 0.66, so it's around here, like this. And even more, we have 108 and class width of 60 to 100, so it's like very small rectangle, small layer like here. So just remember, density is frequency over class width. So the value, the area of each bar will get us back to our frequency. And that's it for today. Thank you for watching.